എടുക്കണം നോക്കണേ സഹദ്. ഒന്ന് ആബ്സെന്റീസിന്റെ നമ്പർ ഒന്ന് നോട്ട് ചെയ്യണേ. നമ്മൾ അറ്റൻഡൻസ് എടുക്കുമ്പോൾ ഒത്തിരി സമയം പോകും. ഇപ്പൊ വരുന്ന ഒന്ന് എന്തെങ്കിലും ഒരു ഷോട്ട് എടുത്ത് വെച്ചോ. 53 പേരാണ് പ്രസന്റ്. അല്ലെങ്കിൽ 2 മിനിറ്റ് കൂടെ വെയിറ്റ് ചെയ്യാം. ഫാത്തിമ റെക്കോർഡ് ചെയ്യുന്നുണ്ടോ?
റെക്കോർഡ് ചെയ്യുന്നുണ്ട്.
തുടങ്ങിയോ?
സാർ തുടങ്ങി.
പോസ് ചെയ്തോളൂ. So good morning. We'll see coupled circuits. We have seen earlier. Now we are seeing it again quickly so that things will be very clear to all of you. So here, in coupled circuit, you will be given with the dot. So all of you know the dot convention. So here in this circuit, let us consider this circuit. Let us see things slowly. Start with. Here there are 2 windings. There is an inductance L1 and there is an inductance L2. These 2 coils are called coupled coils. This inductance, when current goes through this coil, what happens? There is a self-inductance which will oppose the current. That opposition is given by L dI1 by dt. Together with that, there will be an opposition because of the current in coil 2. And that opposition is given by M dI2 by dt. It is, please note, it is dI2 by dt. So when current is going through this coil 1, there are 2 oppositions. One opposition is coming from the self-inductance, which is because of the flux produced by current 1 and linking with coil 1. And there is an opposition because of mutual inductance. It is because of the flux produced by current in coil 2 and the flux linking with the coil 1. And that is given by M dI2 by dt. We have seen a lot about mutual inductance in the last class. Whereas if you consider this circuit, V2 will be equal to M dI1 by dt plus L2 dI2 by dt. So the dot polarity convention is when they assume current enters both. Here, if you look here, the current is entering the dotted terminal. When the current enters both or leave both the dotted terminal, the sign of M term will be same as the sign of N term. So in this case, current is entering to the dotted terminal. Because of that, we have the same sign for L and M. Look at this dependent source. When we start using dependent source, things will become clearer. Okay, when we start using dependent source, things will become clearer. In our first module, we had first encounter with dependent source. Now we are seeing it again here. So another way of writing that equation is using this diagram. You see here, what is V1 now? It is L1 dI1 by dt. We know that when current goes through an inductance, there is an opposition given by L1 dI1 by dt. Together with that, there is an opposition because of current in the other coil. That is denoted by what? M dI2 by dt. And what about the second coil? It is V2 is equal to L2 dI2 by dt plus M dI1 by dt. Look here, the current is entering the dotted terminal. This portion is easy, and this dot convention, once you understand it, there is no big deal in it. So the equations are here. V1 is equal to L1 dI1 by dt plus M dI2 by dt, and V2 is equal to L2 dI2 by dt plus M dI1 by dt. Look at here, the current is entering this dotted terminal and current is leaving this dotted terminal. Because of that, the sign of M is negative. The sign is not same. So what is V1? V1 is L1 di1 by dt minus M di2 by dt. And V2 is minus M di1 by dt plus L2 di2 by dt. So let us pause for a while. Gauri is there? Gauri,
Yes, sir.
please explain the slide.
V1 equal to L1 di1 by dt plus M.
So let us consider a simple circuit like this. Unmute me and Gauri. This voltage is V. RMS value is V angle 0. Okay. This is R. How will I find the steady state current in this circuit, Gauri? How will I find the steady state current, Gauri? Or Fatima? Fatima can tell. Fatima, or how will I find the current? How will I find the current in this circuit? This inductance is L. I want steady state current. What is that? Fatima?
Voltage L di by dt ആണ്. അപ്പോൾ
voltage across this is L di by dt. And
Yes,
I'm asking you what will be the reactance here. I'm doing sinusoidal current. When the current is sinusoidal, what will be the current?
sinusoidal current.
AC circuit പഠിച്ചിട്ടില്ലേ?
Yes, sir. Sir, എനിക്ക് ഓർമ്മയില്ല.
ഗൗരി ഒന്ന് അൺമ്യൂട്ട് ചെയ്യാൻ പറ്റുമോ? ഗൗരി അൺമ്യൂട്ട് ചെയ്യാൻ പറ്റുമോ?
Sir.
Yes. What will be the sinusoidal steady state current? I will give you another question. This we have done one day. I will give you values. This is 10 sin 314t. This is 5 ohms. This is 2 Henry. How will I find steady state current? Gauri.
Vm sin omega t.
Vm sin omega t ഉണ്ട്. സഹദിനെ ഒന്ന് അൺമ്യൂട്ട് ചെയ്തേ ഫാത്തിമ.
Okay, sir.
Sahad. Yes, how will I find current in this circuit? Voltage is 10 sin 314t.
Sir, 5
this is
plus
given.
Sir, 2 Henry അല്ലേ? അപ്പോൾ 2 Henry XL കണ്ടുപിടിക്കാം. XL plus
XL കണ്ടുപിടിക്കണം. Good. XL എത്രയാണ്?
XL plus 5 അത് L omega അല്ലേ? അപ്പോൾ omega is equal to 2 pi f, frequency 50, അവിടെ എന്താ 314 omega 314.
So 314. So there is good. I will repeat what Sahad has said. Z is equal to R plus j omega L. And if I want the RMS value of the current, it will be V RMS divided by Z. If I want, we'll talk only about RMS value. If I want RMS value of the current, it will be V divided by Z. Omega is 2 pi F. Sahad ഒന്നുകൂടെ പറയാമോ അത്?
ഇപ്പൊ R നമുക്ക് 5 എന്നറിയാം. ഇനി L നമുക്ക് 2 എന്ന് കിട്ടി. ഒമേഗ അക്കോർഡിംഗ് ടു ദി ഇക്വേഷൻ 314 ആണ്. അപ്പോൾ 314 into 2 ചെയ്യാം. അപ്പൊ നമുക്ക് ഒമേഗ L കിട്ടും. പിന്നെ J മീൻസ് 90 ഡിഗ്രി ആണ്. അപ്പോൾ അത് പ്ലസ് 6 ചെയ്യാം. പിന്നെ വോൾട്ടേജ് ആയിട്ട് ഡിവൈഡ് ചെയ്താൽ മതി റെസിസ്റ്റൻസ് കിട്ടിയ. സോറി, RZ effective resistance RZ.
Oh, so I'll repeat this. So this is something very fundamental. If I finish today's portion, I'll give you, I have given a revision earlier. I'll give a revision again about AC circuits. So sinusoidal steady state means we are interested in the steady state current. Suppose we are having a sine wave. The current through this circuit will be what? The current through this circuit will be what? V RMS divided by J omega L1 plus J omega I2. There is no R here. It is J omega L1 plus J omega I2. And what will be V2? V2 will be equal to J omega L2 I2 plus J omega M I1 I2, or I2 will be equal to V2 divided by J omega L2 plus J omega M I1. So look at here. Here current is leaving the dotted terminal. So the sign of omega M is a sign of M is same for sign of M and L are same. So I will get what will be V1 here? V1 will be equal to J omega L, J omega L1 I1 plus J omega M I2. So I cannot find I1 very easily when I am having this kind of circuit. I'll have V2 is equal to what? V2 is equal to J omega L2 I2 plus J omega M I1. Let us write the mesh equation for this network shown. Here, I will help you to think. So here, look here. Here, the dot current is entering through this dot. And what is the current entering through this dot? It is, I'll call this current as I1. The loop branch current, the loop current is I1. The mesh current is I1. This current is I1. What about this dot? Current is entering here. Current is entering this dot also. So what will be the equation for this? I'll write here R1 I1 plus L1 dI1 by dt plus R2. What is the current here? Current here is I1 minus I2 plus L2 d I1 minus I2 dt. And there is this mutual inductance. What is the sign of mutual inductance in both these cases? It will be the same as sign of self-inductance. I'll write here mesh 1, it will be R1 I1 plus L1 d I1 by dt. Together with that, you write the mutual inductance term plus y plus M12 d I1 minus I2 by dt plus R2 I1 minus I2 plus L2 d I1 minus I2 t plus M12. It will be d I1 by dt. I have typed it neatly in the next slide. Let us go to the next slide. So look at this diagram. So in terms of, so what is V1 t? R1 I1 t plus L1 d I1 by dt plus M12 d by dt of I1 minus I2 plus R2 I1 minus I2 t plus L2 d d by dt of I1 minus I2. And there is a mutual inductance because of M12, and there's another mutual inductance because of this. This mutual inductance, what is the sign for M12? M12 sign is positive. Look here, M12 sign is positive. Whereas M23, this is the dot corresponding to coil 2 and coil 3. So here the current is leaving coil 2, whereas current is entering coil 3. That is why we have a negative sign. And what about this part? L3 d I3 by d I2 by dt. And what is this? This sign is minus. Why the sign is minus? Current is entering here, whereas current is leaving here. So equations are written here. V1t is equal to, let us look again, V1t is equal to minus R1 I1t minus L1 d I1 by dt minus M12 d by dt of I1 minus I2 minus, so here it is plus minus R2 into I1 minus I2 minus L2 into d by dt of I1 minus I2 plus M23 di2 by dt and minus M12 di1 by dt. Similarly, if you consider this loop, what will I start with? There's a voltage rise here, M12 di1 by dt. There's a voltage drop here, minus M23 di2 by dt. And there's a voltage drop here, because I'm assuming this is plus and this is minus, this is plus and this is minus, minus L2 di2 by d1, d by dt of I2 minus I1, minus R2 into I2 minus I1, minus L3 into di2 by dt, plus M23 into d by dt of I1 minus I2, minus R3 I2 equal to 0. So let us understand this problem clearly. So who is 72, Fatima?
Sir, Nana 72.
Fatima R is 72. Who is 71?
Said Ali.
Said Ali, can you explain this? Said Ali undo. One question on the why Said Ali.
Write mesh equations for the network shown.
Okay, we'll go to the next slide. Pointer. Yes, Said Ali.
L1 L2 starting point dot mark ചെയ്തിട്ടുണ്ട്.
അപ്പോൾ ആദ്യം നമുക്ക് ഈ ലൂപ്പിന്റെ മാത്രം പറയാം.
I1 R1 minus I1 R1 minus L1 di by dt plus M12 d of I1 minus I2 by dt plus IR2 plus L di1 by dt minus M23 di2 by dt plus M12 di1 by dt.
Yes, tell me about this sign. Why this is plus and this is minus, Said Ali? Said Ali's connection power 73 arana, 73 arana.
Gauri.
Gauri പറഞ്ഞേ എന്തുകൊണ്ടാണ് ഇത് പ്ലസ് ഇത് മൈനസ് ആവാൻ കാര്യം? ഗൗരി
എൻ്റർ ചെയ്യുന്നതുകൊണ്ട്,
രണ്ടിലും എൻട്രി ചെയ്യുന്നതുകൊണ്ട് M12 പ്ലസ് ആയി. ഇത് എന്തുകൊണ്ടാണ് മൈനസ് ആയത്?
ലീവ് ചെയ്യുന്നുണ്ട് ഡോട്ട്.
Okay, the best thing will be I will pause, write the equation, read this question, Fatima. You can stop recording.
Write mesh equations for this network shown.